This is my mastery assignment for Module 5, and the first topic we're going to cover today are separable differential equations. A separable equation is a first-order differentiable equation in which dy dx can be written as a product of a function of x and y, and here's an example of that. These types of equations lend themselves to finding antiderivatives, and we can let that be known as what's written in purple here. And step 1 is always to separate the variables, and you can see that here. Here are 3 basic steps you can use when solving separable differential equations. Here's the first example asking you to solve the differentiable equation dy over dx equals x squared over y, and y cannot equal 0, and the initial condition is y of 0 equals 3. First, you'll separate the variables and then integrate them to get the antiderivative shown here. Then you will move everything to one side to get y squared equals 2x to the third power over 3 plus c, and then you can use that to plug in your initial condition, and c will equal 9, and then your final answer will be y squared equals 2 over 3 x cubed plus 9. The next topic I will cover are position, velocity, and acceleration. The position is the location of an object as a function of time, and the velocity is the rate at which an object is moving, expressed as a ratio of units of distance divided by units of time. And acceleration is the rate where velocity of an object is changing, and it's expressed as a ratio of units of distance divided by units squared. In this example, a flower pot falls and hits the ground 30 feet below. Time is in seconds. How long does it take for the pot to hit the ground, and at what velocity does the pot hit the ground? It's important to note that gravitational acceleration is negative because it is going downward, and therefore it is known that a of t equals negative 32 feet over a second squared. First, you have to separate your variables and then integrate to get the antiderivative negative 32t plus c, and we can conclude that c equals 0, and so the formula will be v equals negative 32t. To get the position, you do the same steps, separate, then integrate to get position equals negative 16t squared plus 30. Then you plug in your initial condition, and you can conclude that t equals square root of 30 over 4. This answer answers the question of how long it will take for the pot to hit the ground. Now you will take that answer and plug it into the velocity formula for t, and this will answer at what velocity the pot hits the ground. And this answer is negative 8 times square root of 30. Hope this helped, and thanks for watching.